Alright, our agenda for today is we're going to start by watching the video and taking notes and working. When you're finished watching the video and taking notes, I want you to show your notes to the substitute, and then you have the rest of the period to work on your homework. Our homework is what's listed on the calendar as assignment number 5 in your book. By the end of class today, you should be able to solve a trig equation for both specified and general solutions. Alright, so let's take a look at example number 1, solving a trig equation for both specified and general solutions. Here we go is a very basic example. Sine of x minus square root of 2 equals negative sine of x. So you're going to solve this just like a normal equation where you want to isolate your sine of x. So I'm going to add sine of x over to the left side to get 2 sine of x minus square root of x, square root of 2 equals 0. Let me go step by step. And then you are going to add the square root of 2 over to the other side. And then we're going to divide by 2. So we get sine of x equals square root of 2 over 2. So what we need to do is we need to figure out which triangle made this this sine value. So we make our quadrants, and sine is positive in quadrants 1 and 2. All students take calculus, so sine's positive in quadrants 1 and 2. So if you make your triangle, we have a square root of 2 over 2. So sine is opposite over hypotenuse. So that means that we have opposite over hypotenuse. So square root of 2. Hypotenuse is 2, which this is our 45, 45, 90 right triangle, because this is the same exact triangle as 1, 1, square root 2. Back to our two right triangles, 45, 45, 90. Or our 30, 60, 90 right triangles. So this one matches that. It's just multiplied by the square root of 2. So that means our reference angle is 45 degrees, or pi over 4. So this angle here is pi over 4. And this angle here is going to be 3 pi over 4, which you can get by doing pi minus pi over 4. So those are two specific angles within the domain of 0 to 2 pi. To find the general solutions now, we're going to want to, in this case, have to get back there by adding 2 pi. So our general solutions are going to be pi over 4 plus or minus 2 pi n, and 3 pi over 4 plus or minus 2 pi n. And then our two specific solutions between this given domain is pi over 4 and 3 pi over 4. Alright, let's take a look at example 2. So example 2, again, we're solving, but in this case we have sine squared, so we're going to end up having to take the square root. So we first start by adding the 3 over to the right side. Then we want to divide by 4. So we get sine squared of x equals 3 over 4. Take the square root of both sides. Don't forget plus or minus whenever you have to physically draw in square root. And so we get square root of 3 is square root of 3, square root of 4 is 2. So we get plus or minus the square root of 3 over 2. So we'll have 4 possible answers now between 0 and 2 pi, because sine is positive in quadrants 1 and 2, but negative in quadrants 3 or 4. So since we have that plus or minus, we end up getting 4 possible answers. So if we take a look at our triangle, which I'm going to draw separate just because of space. In quadrant 1, remember sine is opposite over hypotenuse. So we have opposite is square root of 3, hypotenuse is 2. So this matches our 30, 60, 90 right triangle with our reference angle being 60 degrees. So that means in quadrant 1, that's pi over 3. In quadrant 2, that's 2 pi over 3, which we can get by doing pi minus pi over 3. In quadrant 4, that's 4 pi over 3, which we can get by doing pi plus pi over 3. And then in quadrant 4, that's 5 pi over 3, which we can get by taking 2 pi minus pi over 3. So those are our 4 answers between 0 and 2 pi. To find our general solutions, notice we have a straight line here between pi over 3 and 4 pi over 3, which means that those are exactly 180 degrees apart, or exactly pi apart. And same thing between 2 pi over 3 and 5 pi over 3, they're exactly pi apart. So our general solutions are going to be pi over 3 plus or minus pi n, and 2 pi over 3 plus or minus pi n. And again with the 4 specific solutions between 0 and 2 pi. Alright, and sometimes you have to factor in order to solve. So in this example here, we want to subtract the 2 cotangent of x over to the left side, and now both of my terms have cotangent in it. So you want to factor out a cotangent of x. So we get cotangent of x times cosine squared of x minus 2 equals 0. So then we have our 2 factors multiplied together to equal 0, so we can split them up, set them equal to 0, and solve. So cotangent of x equals 0. Cotangent, remember, is the reciprocal of tangent. So that means tangent of x is undefined. Or cotangent, remember, is cosine over sine. So what this is really asking is where is cosine of x 0 and where is sine of x 1? And that answer is in 2 locations, at 0 and at pi. Right here and right here. Because remember, those are our coordinates. I'm sorry, that's a mistake. It is not at 0 and pi. It is at pi over 2 and 3 pi over 2. Because at 0 and pi, cosine is 1, sine is 0, which would make cotangent undefined. So it's actually at pi over 2 and at 3 pi over 2. Because that's where sine is 0, cosine is 1, or sine is 0, cosine is negative 1. But either way, that's where we get cotangent to be 0 and tangent to be undefined. So our specific solutions, from the cotangent of x being 0, we get pi over 2 and 3 pi over 2. Now let's look at cosine squared of x minus 2 equals 0. So I would add 2 over, and then it's cosine squared, so I have to take the square root of both sides. So we get cosine of x equals plus or minus square root of 2. But that's not possible, because remember, cosine is adjacent over hypotenuse, and it is not possible for your adjacent side to be larger than your hypotenuse, because square root of 2 is larger than 1. So this side gives us no solution. So we only get two solutions from the cotangent of x being 0. So we get our general solutions. I can't erase that. So we get our specific solutions between 0 and 2 pi to be pi over 2 and 3 pi over 2. And our general solutions will be pi over 2 plus or minus pi n, because again it's exactly pi apart, so we can only need to keep adding or subtracting a pi. Here's another example where we may have to factor. So I have sine squared of x equals sine of x, so I'm going to subtract sine of x over, factor out a sine, so I get sine of x times sine of x minus 1. So we have our two factors, which I can set equal to 0. So we get sine of x equals 0, sine of x minus 1 equals 0. So we get sine of x equals 0. In two places, at 0 and at pi, because remember that coordinate is 1, 0, so sine is 0, and negative 1, 0, so sine is 0. So we get two specific solutions at 0 and pi. And then now when we set sine of x minus 1 equal to 0, we're going to add 1 over. So sine of x equals 1. Again, think about your quadrants right here at pi over 2, or the coordinate 0, 1, is where sine of x is equal to 1. So we have three specific solutions between 0 and 2 pi, and then our general solutions. If we think about our three possibilities, we can take 0 and keep adding pi, keep adding pi, keep adding pi. That's the first general solution. Or we can take the pi over 2 and keep adding 2 pi. So that's our second general solution. So plus or minus pi n, and then pi over 2 plus or minus 2 pi n. Another set of factoring, or possibly if it didn't factor, having used quadratic formula. We can see it looks like a normal quadratic. We have a sine squared, then a sine, then a constant. This does factor to be 2 sine of x minus 1, sine of x minus 1, which we would have to just get, I guess, and check. So we set our two factors, set them equal to 0. So we have 2 sine of x minus 1 equals 0. Add the 1, divide by 2. So sine of x equals 1/2. Again, sine is positive in quadrants 1 and quadrant 2. Draw your triangle. Sine is opposite over hypotenuse, which means this is our 30, 60, 90 right triangle, with our reference angle being 30 degrees. So that's pi over 6 and 5 pi over 6. Now sine of x equals 1, sine of x equals, sine of x minus 1 equals 0. Add the 1, so we get sine of x equals 1, which is again on an axis right there. So at pi over 2. So I have three possible general solutions, or sorry, specific solutions. Pi over 2, pi over 6, 5 pi over 6. And then the general solutions, which this one did not ask for, but if we did want to, we would have to do pi over 6 plus or minus 2 pi n, because we'd have to keep going around. Same thing with pi over 2 plus or minus 2 pi n, because in order to get back here, we have to keep going around. And then same thing with the 5 pi over 6 plus or minus 2 pi n. in order to get here, we'd have to keep, going around. No shortcuts. All right, converting using identities. So here we have a sine of x plus 1 equals cosine of x. There would be no possible way to solve, could not solve it by factoring. So what we could do is we could use a little bit of math magic. We could square both sides, and I know that I have to do that because sine by itself doesn't help me out. Cosine by itself doesn't help me out. So if we square to get a sine squared or a cosine squared, we can actually get some stuff done. So we start by squaring both sides. So when I square sine of x plus 1, we get sine squared of x plus 2 sine of x plus 1 equals cosine squared of x. And now I can change cosine squared of x to be 1 minus sine squared of x. So now we're going to have to factor, hopefully. So subtract the 1 over, add the sine squared of x over, we get 2 sine squared of x plus 2 sine of x equals 0. Can factor out a 2 sine of x, so we get 2 sine of x times sine of x plus 1 equals 0. So now we can split up our two factors, set each one equal to 0, and solve. So that's 2 sine of x equals 0. Divide by 2, sine of x equals 0. So look at your quadrants. Sine of x equals 0, at 0, and pi. And sine of x plus 1 equals 0. So we subtract the 1, so we get sine of x equals negative 1. Right there at 3 pi over 2. And now since we squared, we have to double check all solutions to make sure that none of them are extraneous. So if we go back up to the top, let's check x to be 0. So sine of 0 plus 1, does that equal cosine of x? Well, sine of 0 is 0, plus 1 is 1. Cosine of 0 is 1, and 1 equals 1, so we're good there. If we check pi, sorry, looking for an eraser, there we go. Sine of pi is 0, plus 1 gives us 1, but cosine of pi is negative 1, and that's an extraneous solution, so that does not count. And that happened because the squaring popped up, so that's no longer a solution. And then check 3 pi over 2. So sine of 3 pi over 2 is negative 1. Negative 1 plus 1 is 0 on the left side. And cosine of 3 pi over 2 is sorry, I got my sine and cosines mixed up. Erase. Start that over. Sine of 3 pi over 2 is negative 1. Plus 1 is 0. And cosine of 3 pi over 2 is 0, so we get 0 equals 0, so we're good. So 0 was good, pi turned out to be extraneous, and x equals 3 pi over 2. So we get two solutions here, 0 and 3 pi over 2. And then finally, number 7, converting using identities. Sorry, not finally, we have one more example. So here we have a secant and a tangent. So we can either turn the secant squared into a tangent squared or vice versa. I chose to change the tangent squared of x into a secant squared of x. So we have 3 secant squared of x minus 2 times secant squared of x minus 1 minus 4. Have to distribute that negative 2. So we get 3 secant squared of x minus 2 secant squared of x plus 2 minus 4 equals 0. So combine the like terms and we get secant squared of x minus 2 equals 0. add the 2 over, secant squared of x equals 2, square root both sides, so we get secant so we can either square root right now and get secant of x equals plus or minus square root of 2, which means cosine of x equals plus or minus 1 over square root of 2. Or you could flip first, then square root. It doesn't matter, but either way, cosine is positive in quadrants 1 and 4, negative in quadrants 2 and 3. And if we draw in our triangle, cosine is adjacent over hypotenuse. So adjacent is 1, hypotenuse is square root of 2, which means that's our 45, 45, 90 right triangle. So that's pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So those are our 4 solutions between 0 and 2 pi. And if we wanted to do general solutions, it would be pi over 4 plus or minus pi over 2n. Because each one, if you take a look, are exactly 90 degrees apart, or 4 pi over 2 apart. So we can get to every single one over and over again by adding and subtracting a pi over 2. And there is no really trick to knowing that, you just have to look. So the last example is solving a trig equation off of the unit circle. So same steps as before, you're going to add the 2. No, I'm sorry, subtract the 2 over to the right side, divide by 9, square root, so we get tangent of x equals plus or minus 1 over 3. And if you did your triangle, tangent is opposite over adjacent. We don't have a triangle that matches that. That's not your 30, 60, 90. That's not your 45, 45, 90. It's pretty close to it, but it's not quite, so it's not on your unit circle. So the only way to do this is you have to use your calculator. So tangent negative 1 plus or minus 1/3. You have to do it 2 separates, one with positive 1 over 3, one with negative 1 over 3. And we end up getting those 2 possible answers. So then, again, we use that as a reference angle to find our 4 possible solutions. So we have 0.322 that we got, and then in quadrant 2, we're going to take pi minus that to get our second answer. In quadrant 3, we're going to do pi plus that to find our third answer. And in quadrant 4, we're going to do 2 pi minus that to find our fourth answer. Alright, that's our lesson for today. Sorry, it was a little rush. I really was hoping to be back today, but this flu is really kicking my butt. So hopefully I'll be able to be back with you guys tomorrow. And we're going to, spend another day or so on this lesson. So today's not the only day. Alright, so when you're done, go ahead, show the substitute your filled in notes, and you have the rest of the period to work on your homework. It is in the book, but remember you can pull up the online version of your book or go grab your book from your locker.